This is Dr. Carroll, and this video is a short introduction to debugging and testing. So debugging is also known as detective and work and troubleshooting. And so in some ways it can be very enjoyable if you enjoy that sort of thing, to be able to track down and have a challenge to be able to figure out what's going on. So in general there's two major steps, and one is to make a prediction, meaning guess what is the cause of the problem, have a hypothesis. And then the other step is, well, try out an experiment. And so what you want to do is you want to isolate the problem and boil it down to the simplest form possible, and then you can create it. If you're, for example, trying to submit a bug report to some large program or somebody else in your company that has over a large unit or module, you say, hey, there's something wrong with your program, that's very different than saying, hey, this one part, if you boil it down, there's something wrong here. I try and make this call to this class or this method and it breaks. Well, that's a lot easier to figure out. So if you boil it down and focus down on it, often that will reveal the problem and what's going on. And so to do so, you may need to hard code one or more values, or copy the relevant part to a new file and work that down until you have very little code and that is still exhibiting the incorrect behavior, and you might need to iterate on this a little bit. So debugging is really reactive, whereas to be proactive we would employ testing. And so a good analogy here is, would you dream of making some food and serving it to some guests without tasting it first? What if it turned out wrong? What if it's a new recipe? Or an even better analogy would be, if you're serving to a customer or client that has paid a lot of money for that food, would you want to make sure that it worked correctly? Oh, sorry, I'm getting ahead of my analogy here. That it tasted good and that you were confident that they were going to be well pleased with it. Well, so that's how I want you to think about testing, is that it is proactively verifying that everything is working properly. So let's talk about some ways to accomplish that. First is test cases. And so with test cases, it's specifying the input and the expected output. We say this is a test case. And so this is what is going to go into the system, and this is what we expect out of the system. And so that is the framework for a test case. And so given that we're dealing with inputs, good test cases include boundary values. So what's a boundary value? If you're testing if something is a positive number, see how things work if you give it 0, if you give it 1, if you give it -1. Those are boundary values right around values or thresholds that make a difference. If you're testing, for example, for social media, generally the age is 13 to have a social media account. Well, what happens if you put in 12? And if you're not working with whole numbers, what about 12 and a half? What about one day shy of 13? What about 13 on the birth date, or one day after? And so those are examples of boundary cases. And so typically what we're dealing with test cases is a range of valid measurements. And so if the range is what you're testing, you want to have some test cases in that range, and you want to look very closely at both sides of the boundaries, a little bit above, a little bit of below, to be confident things are working correctly. Now let's talk more specifically about unit testing. So with unit testing, this is where we're testing a small part, a unit of the code. And so you can think of this as a method or even a class. And so this unit test is part of a test bench or a test harness. And so each test has input values and expected output values, and that we're testing. So just like a test case. And so this is an important technique to help reduce bugs, because we can look at one part of it and we can work on it. And so good developers write unit tests for each class as they go to be able to figure it out. And sometimes when you're writing the test, you will recognize that it's not going to pass the test, and you go update the code. So the goal of unit testing is to have 100% code coverage. Now, what does that mean, code coverage? That means every line is executed. So you want your test to force every line to be executed. Now, this does not guarantee you found all the bugs, but you can't be confident if you don't have 100% code coverage that you have found all the bugs. Even there's parts of the code that don't even work. That would be like serving some food and it's, well, I didn't try the desserts, but the rest of the food was good. So dessert's probably good too. That's a little scary situation to be in terms of what your customer is going to think, and you're going to get any repeat business and things along those lines. It's important to keep in mind that testing often takes about 50% of the total development time. And so you may be thinking, oh, this is extra, but it's not something you do if you have extra time. It's something you always do to be able to produce a high quality product. And with testing, the convention is that you only display something when it fails. So you could have hundreds, thousands of tests, just display when they fail. Otherwise, you get lost in all the pass, and you just need to know when it fails, because hopefully almost all of them pass, if not all of them, and you need to focus on the ones that fail. To look into more information about this for unit testing, you can look into JUnit. It's a very popular framework that is well used. To wrap up this video, let's talk about regression testing. So this is where we rerun all tests each time the code has changed. And so if you can imagine code is being changed, we have these tests already set up. And so what we're doing is we're saying, hey, the code changed, let's make sure it still passes all of the tests. And so the name regression testing comes from if you have code that used to pass one or more test cases, and it's changed and it no longer passes one or more test cases, then we say the code has regressed. And so that's where the name regression testing comes in. I hope you enjoyed this.